Well, welcome back from lunch. I hope you all enjoyed the morning session. And just to orient yourself, this is the session on the smart connected machines. And my name is Spada, and I'm from one of the research analysts from ARC. And my coverage is primarily in the discrete manufacturing center. So today joining us in this particular session will be Rocky Rowland from Mazak Corporation, and Keith Holliday from Global Drilling Solutions. Okay, and along with them, what they'll be presenting, and in case you're not familiar with the format, both Keith and Rocky will be presenting, and then joining them on the panel will be Steve Pawlowski and Florian Goodner. Steve is from GE, and Florian Goodner is from ARC and one of our analysts from the European market. So he's going to give us the perspective from the European perspective on the smart connected machines. So with that, I'd just like to get going so we can make the best use of our time. And if you have any questions, certainly jot them down on paper and reserve them for the panel session. We'll certainly entertain them at that point. Okay, so, and then we'll go around with the speaker, with the microphone, and we'll work it from there. But thank you. So today we're talking about smart connected machinery. It's kind of a hot topic in the industry. And one of the things that I like to look at is certainly what's the business fundamentals behind it? What drives people to connect machinery? And if you look at some of the, excuse me for 1 second, Matthew, the screen up here isn't working. Okay, thank you. Okay. So one of the things that I look at is some of the underlying business fundamentals, and that is, profitability. Everybody tries to run their business at the maximizing profit. I did some research about a year or two ago, and you look at the relative ranking of profitability in some of these industries, and machine tool builders get down near the very bottom, unfortunately. Automotive manufacturing, surprisingly, not surprisingly, down near the bottom as well, but farm and construction. So a lot of machinery builders are hovering near the bottom of the spectrum in terms of profitability. So what do we need to do? We need to think outside the box in terms of leveraging new ways to improve margins, improve growth in the business. So one of the things we think about is enhancing business performance, and we've all been talking about it, enhancing it through the industrial Internet of Things. And so a lot of machine builders are looking for new revenue streams, services. We're all talking about services, additional services, spare components, spare parts, and other types of services that we're looking at in the future in terms of improving productivity, helping people predict their maintenance, and things of that nature. So we're looking at this industrial Internet of Things, the smart connected machine, as a way to generate new sources of revenue in the business. So one of the things we look at is the challenge that the machine builders are facing in terms to make this all work, because we're not looking for isolated point solutions. We're looking for complete solutions. So that means connecting your entire components within your machinery, which could be subsystems, sensors, higher level intelligence embedded in the machinery. We need to look at ways of collecting data through data acquisition systems, and then performing some sort of analysis, and then connecting this through some sort of whether wireless, mobile applications, etc. So in the end, we're looking at putting together a true ecosystem, an ecosystem that, once deployed, fulfills really all the elements of a smart connected machine in an environment that can provide services. And so this is ARC's model for the industrial Internet of Things and an ecosystem that sits around a smart connected machine. And what we expect in the end from smart connected machines is to close the gap in availability, improve availability overall through equipment protection algorithms so machines don't damage themselves, run them into failure. Maybe improving performance through adaptation of the machine to variations of materials and workloads, and also doing predictive condition monitoring so that we can predict failure before actually you have to go down. So there's a tremendous amount of there's a tremendous amount of effort being done in this area in some other industries that you may or may not be familiar with. And I look at companies like Caterpillar, poster child, I think, for building the smart connected machine. They've built the ecosystem. They haven't built it on standards or openness, but they've gone out, built these complex environments where they're able to track and monitor their machines in very rugged and rigorous environments. And they've even taken it to a new level. In fact, if you dig a little bit deeper, what they're doing is they're not only tracking their machinery, but they're tracking the roads and the quality of the road systems in the mining facilities and actually adding that to their predictive algorithms to recognizing that the machines are running over rougher roads or more rugged roads, and they're actually going to start to wear earlier. So there's a lot going on even in the mining industry where we see a lot of innovation, a lot of the things we're talking about here in terms of bringing connectivity, intelligence, predictability, and analytical technology into the whole spectrum. So with that, I wanted to leave you with the whole idea of where you can go with the smart connected machine and what's already happening in the industry today.